One of the most well-known distributions is called the normal distribution, also known as the bell-shaped curve. The normal distribution is one of the ways we display continuous numerical data. It draws from both the organise, summarise and display data step in the statistical investigation process, as well as the descriptive or summary statistics step in the statistical investigation process, where we analyse the data. In this video, we're going to have a look at the normal distribution, a reminder of what continuous numerical data is. We'll have a look at class interval size, how the normal distribution arises, the normal distribution curve properties, and we'll look at sketching the normal distribution. The normal distribution is the most important distribution for continuous numerical data. This means things that are measured such as height, length, weight, time, etc. Many observable quantities have distributions that are normal or approximately normal. A normal distribution is bell-shaped, symmetric, and has a single peak. A normal distribution is described by giving its mean and standard deviation. Numerical variables are given in numerical number form. The information collected is numerical data. Continuous numerical data represents measurements. These values cannot be counted, can only be described using intervals on the real number line. They take on values within a certain range and are usually rounded and take on an infinite number of decimals. Continuous numerical data is displayed in frequency distributions and histograms. A frequency distribution is a summary table in which the data is arranged into numerically ordered class intervals of equal width. A graph of data in a frequency distribution is called a histogram. Bars of the appropriate height are used to represent the number of observations within each class. We've already seen in my displaying continuous numerical data video that it can be displayed using a histogram in which data is arranged into numerically ordered class intervals of equal width. Attention needs to be given to selecting the appropriate number of class intervals and therefore determining a suitable width of groupings. As you can see here, a histogram of the same data set can look very different when the class interval size is decreased. As it is decreased, the data set begins to look more like a bell-shaped curve or a normal distribution. You'll notice that the distribution is symmetric and has a single peak. The normal distribution can arise when many different factors affect the value of the variable. Data points or observations are themselves combinations of many random factors. Think of each observation or data value as a result of the interplay of a set of random independent factors. Each observation or data value is basically a result of combined effect of independent factors pulling the observation higher or lower than the mean observation. The result is that most of the values will be centered around the mean, and there will be fewer values as they get further away from the mean. The probability of having a set of random factors that come together to create an observation that are much higher or much lower than the mean gets smaller and smaller the further away from the mean the observation gets. This is because the observation needs an increasing number of combination of variables that pull them in the same direction further from the mean. We'll look at this further. Generally, normal distributions have the same bell-shaped curve. However, the exact location and shape of the curve is determined by the mean and standard deviation. For example, the height of a building in a city may be normally distributed with a mean of 10 meters and a standard deviation of 3. So the mean goes in the middle. Most of the buildings are close to the middle or the mean. For any normal distribution, no matter the values of the mean and the standard deviation, the proportion of values within 1 standard deviation, 2 standard deviations, and 3 standard deviations is constant. We're going to explore that further now. As you can see here, the proportion of values within 1, 2, and 3 standard deviations of the mean for a normal distribution is constant. For any measured variable from any population that is normally distributed, approximately 68% of the population will lie between 1 standard deviation of the mean, and you can see that here. There's 34.13 to the left and to the right of the mean. Approximately 95% of the population will lie within 2 standard deviations of the mean. So now we're including that 13.59% to the left and right of the mean. Approximately 99.7% of the population will lie between 3 standard deviations of the mean. So that's the mean plus and minus 3 standard deviations. The entire area under the curve is going to be 100% of the population. The percentage of data values that lie within different ranges relative to the mean are shown below. If we know the variable is normally distributed, we can use the mean and standard deviation to predict the percentage of data that will lie within a certain interval. We can also use these percentages to find probabilities. So sketching a normal distribution, begin by drawing a horizontal line or axis. Next, draw a normal bell-shaped curve. Then draw a vertical line from the horizontal axis through the center of the curve, cutting it in half. This line represents the mean of the data and is always located in the center of the normal distribution, as it has 50% of the data above and 50% of the data below it. Label the line with the value of the mean. Then you can sketch in the mean plus and minus 1 standard deviation. Remember, 68% of the population will lie between these. Sketch in plus and minus 2 standard deviations. 95% of the population will lie within these. Finally, sketch in the mean plus minus 3 standard deviations. 99.7% of the population lie between these. Therefore, they're usually out on the ends or the tails of the curve. Remember that the width of the standard deviations must be the same. Suppose that scores on a test are normally distributed with a mean of 35 and a standard deviation of 10. Draw a curve showing the distribution of the scores. Okay, first we draw in our axes and we label it with score because we're looking at scores. Then we draw in our normal distribution curve and we draw in our line for our mean and we label our mean. So our mean of 35, that's given. We draw in 1 standard deviation to the left, 1 standard deviation to the right, and we know what they are. So it's 35 minus 10 would give 1 standard deviation to the left. 35 plus 10 will give us 1 standard deviation to the right. And then we mark in 2 standard deviations, plus and minus, and then we mark in 3 standard deviations, plus and minus. Describe a score of 25 in terms of the standard deviation. So you can see 25 there. We know that it's 1 standard deviation below the mean. What percentage of people achieve greater than a score of 45? All we have to do is add up the areas underneath the curve that are greater than 45. And we know what the percentages are because they're constant. And we can add them together and we get 15.87%. The height of a sample of Year 8 students has a mean of 135 centimeters and a standard deviation of 10 centimeters. Complete the normal distribution below. So we write in height on our axes and we know a mean of 135, and now we plus and minus 1 standard deviation, and we plus and minus 2 standard deviations, plus and minus 3 standard deviations. What percentage of students are less than 115 centimeters tall? Again, we add together the area, the percentage of the area below 115 centimeters. So we add them together and we get 2.28%. If one student was selected at random, what is the probability that they will be less than 115 centimeters tall? What we can do is we can convert our percentage to a probability. We divide by 100 and we get a probability if one student was selected of 0.0228. The circumference of mature apples is normally distributed as shown below. To meet the quality standards, the apples supplied to a supermarket must be within 1 standard deviation of the mean. What is the mean and standard deviation of the apples here? So we know the mean is always in the middle. It's going to be 250 millimeters. Standard deviation, we need to calculate that. So 1 standard deviation from the mean is 255. Take away the mean, 250. So the standard deviation is going to be 5. So we get the mean, or x bar, is 250 millimeters. Standard deviation is 5 millimeters. So what percentage of apples are rejected? So anything above 1 standard deviation and below 1 standard deviation is rejected. So we can draw in our percentages because we know them, they're constant. We can add them all together. We get 31.74% of apples are rejected by the supermarket. What is the probability of an apple will be rejected? Now we can convert our percentage to a probability. We divide by 100 and we get the probability an apple was rejected is 0.3174. So in summary, in this video we've had a look at what the normal distribution is with a reminder of continuous numerical data. We've looked at the class intervals, how normal distribution arises, the normal distribution curve properties, and then we've sketched the normal distribution and looked at some examples. Thank you.